Hello! Yes, and welcome to our Objective 2.7 notes on solving trig equations. This objective, very straightforward. I can solve trig equations. So I want to go over the steps to solving trig equations, and then we'll do some together. The first step is to perform the necessary operations to isolate the trig function. We want to get it all by itself. So it just says sine of theta equals, or cosine of theta equals, or tangent of theta equals. We don't want anything else on that side of the equal sign. Next, we want to identify the angles on the unit circle. So we will definitely need a unit circle nearby while we do these. Now, an important note, often there are more than one solution, so it's important to check the entire unit circle when we're working on solving trig equations. And lastly, again, just double check. Make sure you have identified all the angles within the restriction of theta, and I'll show you what that means in just a sec. So let's do some examples. Notice it says solve the following trig equations. Leave your answers in degrees where 0 is less than or equal to theta is less than 360. So we want angles between 0 and 360 degrees. So first step, isolate the trig function. So we're going to start by dividing both sides by -2. When I do that, I get sine of theta equals -√3/2. So remember that sine of theta is y on our unit circle. So I want to find all the angles where y is -√3/2. So let's pull up our unit circle. The angles where y is -√3/2. Well, let's look around here, and we will be able to find a couple here. First, kind of had that weird movement. So -√3/2. Well, if I'm looking at my y value, I see the positive here. So my -√3/2 is right there. And if I go across, it's also right here on the other side of the y-axis. So since they want degrees between 0 and 360, I would have 240 degrees and 300 degrees as my answers. So I will say theta equals 240 degrees and 300 degrees. And that is our solution. So the sine of 240 degrees is -√3/2. The sine of 300 degrees is -√3/2. Okay, let's do the same thing for letter B here. So to get cosine of theta all by itself, I would need to divide by -6, divide by -6. When I do that, look what I get. I'm going to have, let's see, it'll be -1√3/2 when I simplify that. Sorry, that equals the cosine of theta. So flip it. A negative divided by a negative gives me a positive, so I will have the cosine of theta equals √3/2. Remember that cosine is our x values. So we want to find x values on our unit circle that are √3/2. So let's go ahead and pull out our unit circle. We want to find x values now that are √3/2. So going around my unit circle, I see one right here that is √3/2. And if I keep going around the unit circle all the way back to the fourth quadrant, I have another x value that is √3/2. So since I want my theta in degrees between 0 and 360, I would say that theta is 30 degrees and theta is 330 degrees. So let's go back to our equation here. We would say that theta equals 30 degrees and 330 degrees. There are two solutions. Awesome. All right, letter C. This time we're going to go for tangent of theta, okay? So I'm going to start, let's see here. I would need to add 1 to both sides. When I do that, I would get 0 equals -1/4 tangent of theta. Multiply both sides by -4, I suppose, to get rid of the fraction here. So -4 times 0 is just 0. So 0 equals tangent of theta. So remember that tangent is y/x. So I need to find values where I would have 0/x. So my y value needs to be 0. My x needs to be anything but 0. So let's pull out our unit circle. We're looking for y values of 0. Okay? So I see one right away, right at the beginning. Y value equals 0. And that means there's one on the other side also. So I would have 0/1 here, oh, sorry, I was writing a pin this time, 0 over 1, and I would have 0 over negative 1. Both of those would, in fact, give me 0. So I would say 0 degrees and 180 degrees. So let's go back to our equations. We would say that theta equals 0 degrees or 180 degrees. Notice we don't say 360 because we want strictly less than 360 degrees, less than or equal to 0. So if it's between 0 or 360, we're putting 0, just like we did on this one. All right, so there's some examples of solving equations, leaving our answer in degrees. We can do the exact same process and leave our answer in radians. So let's see what that looks like. Let's look at letter A here. I'd start by dividing both sides by -6. -3 by -6. Well, a negative divided by a negative gives me a positive, so this would tell me that the cosine of theta is 1/2. Remember that cosine is our x value, so I want to find values on my unit circle where x is 1/2. So let's see here, x values of 1/2. Oh, here's one. X values of 1/2. Notice that this one is -1/2, so it's not what we want. X values of, oh, here's the other one. Very good. So first quadrant, fourth quadrant, well done. We find that, remember we're in radians this time, so pi over 3 and 5 pi over 3 would be our solutions here. So let's go back to our equations. We would say that theta equals pi over 3 or 5 pi over 3. Well done. All right, now, letter B, 4 sine of theta equals 2 root 2. Well, divide by 4 to get sine all by itself. I would say that the sine of theta equals, let's see, these would divide. So this would just become the root 2 over 2. Okay, so remember that sine is our y value on our unit circle. So let's go ahead and pull that up. We're looking for y values of root 2 over 2. So going around, well, there's one right quick, and the other one would be right across from that in the second quadrant, root 2 over 2. So we're dealing with radians as our solution, so pi over 4 and 3 pi over 4 would be our solutions for this one. So let's go ahead and write that in. We're saying that theta equals pi over 4 and theta equals 3 pi over 4. Awesome. Last one. -2 minus 2 tangent of theta equals -4. Let's add 2 to both sides. When I do that, I would have -2 tangent of theta equals -2. Divide by -2 to get tangent all by itself. Anything divided by itself is 1. So remember, tangent is y over x. So I am looking for values where y and x are the same. All right? I'm looking for angles on my unit circle where y and x are the same, because when I divide them, that would give me 1. So let's look at our unit circle here. We are looking for y and x that are the same. And actually, as I was erasing that, I see this one right here. X is root 2 over 2, y is root 2 over 2. And then as I go around, notice this one, one's positive, one's negative. That's not what we're looking for. That would give us -1. But hey, if they're both negative, that'll work. So we have pi over 4 and 5 pi over 4 as our values for theta. So theta equals pi over 4 and theta equals 5 pi over 4. And that's how you solve trig equations. If you need some more practice or you're still a little confused, go ahead and check out those sample problems. If you feel like you know what you're doing, go ahead and get started on those practice problems for Objective 2.7. This is Mr. Carter signing off. I'll see you next time.